So Year 10, today we're going to be looking at how the global circulation of air in the atmosphere affects world weather and climate. Have a look at this satellite photograph. You can see lots of white over the continents. What is it? It's clouds, isn't it? And what process therefore is happening in these places where there are clouds? Well, it's condensation. You'll remember from when you looked at rainfall that condensation happens when air rises and cools, and when air cools, any water vapour in the air turns back to water droplets, and that's what clouds are. Now, are they everywhere? Well, if you look carefully, they're actually in bands. So you've got a band of clouds kind of going roughly over the equator area. Then you've got bands of clouds kind of 60 degrees north where the UK is, and 60 degrees south, kind of if you look at southern Africa and southern South America, you can see that band of clouds. And of course, where you have clouds, you also have rain. So there are some parts of the world where there's a lot of rain, some parts of the world where there's not much rain, and those are the parts that actually haven't got clouds. So we've got some key principles that underlie our lesson today. The first one is wherever warm air rises, it cools, the water vapour in it condenses, causing rain. And this leaves low pressure at the surface because the air is rising. So rising air makes rain, RR, rising rain. The second principle is the opposite. As air falls, it warms up and therefore there's no condensation, so it's very dry. So falling air puts a high pressure on the surface. So falling air makes fair weather, and that's the second principle we have to remember. Rising air makes rain, falling air makes fair or dry, clear weather. The third principle is that air moves around the globe from areas of high pressure where the air is falling to low pressure where the air is rising, and this actually moves heat from the equator to the poles. So let's have a look at what causes these bands of rain and clear skies around the globe. First of all, draw a line in the centre of the line, mark on the equator 0 degrees, then mark on a 30-degree north over the Sahara Desert, 60 degrees north over the UK, and 90 degrees north over the North Pole. Now, at the equator, the sun shines really intensely, so the sun heats the ground and then the ground heats the air above it. And this air, because it's warm, it starts to rise. Warm air rises. And as it rises, it cools, and any water vapour that's in that air condenses back to water droplets. And thus forms clouds and then rain. So that's why it's so wet over the equator. Then this cooled air begins to move north and south and then fall back to Earth. And it falls back about 30 degrees north and 30 degrees south, causing high pressure on the Earth's surface. And because as that air falls, it warms up, any water in there, it doesn't condense, and so these areas are dry because condensation and rain is not happening. As the air reaches the surface, it diverges, moving south back to the equator and north. Now, at the poles, the air is very cold because very little sunlight reaches it. The sun is very diffuse, spread out. And so the air over the poles is falling. And because it's falling, no condensation is happening, and you do not get rainfall at the poles. So the air falls when it hits the earth. It again spreads out south, back towards 60 degrees north. The third thing that happens over around 60 degrees north, which is roughly where the UK is, you have therefore cold polar air meeting warmer air coming from the tropics, and they have a battle. It's called a front. It's called frontal rain. What happens, the colder air is a lot denser and the warmer air is forced to rise over the colder air. As this warmer air rises, it cools, any water in it condenses, forming clouds and then raining. So this is why it's wet over the UK. And then once again, that air, as it rises, it cools, and as it cools, it spreads out north and south and then begins to fall again. And so we have a circulation of air around the planet. So in effect, the air is circulating from the equator to the poles via 3 circulating interconnected convection cells, a little bit like cogs in a wheel. And the first cell between 0 and 30 degrees north is called the Hadley cell. The second circulation system is called the Ferrel cell between 30 and 60 degrees north. And then there's a slightly weaker one at the poles called the polar cell. And these interconnect and move the air and move the heat from the equator to the poles. Have a go at adding the cells for the southern hemisphere. It's exactly the same principle but moving towards the south. Hopefully your diagram will look a little bit like this. Now you'll notice at the equator that there are surface winds coming and meeting at the equator, coming from 30 degrees north and 30 degrees south. And this is called the intertropical, because it's in the tropics, convergence, because they're meeting zone, the intertropical convergence zone, the ITCZ. And this is what we could see, that band of cloud across the equator that we saw in our first satellite photograph. Now, what I'd like you to do is have a look at the table, copy out the table underneath this diagram, and I want you to say whether these places are dry or wet. Remember that if air is falling, it's going to be dry because no condensation is happening. If air is rising, it's going to produce rain. It's going to be wet. Also say whether it's high or low air pressure at the surface. If air is falling, it's going to be pressing down, causing high pressure. If air is rising, it's going to be leaving a void at the earth, and that's going to cause low air pressure. When you've done that, try and explain what is going on in each area. So you need to either cross out the wrong words or highlight the correct words in each of the sentences. Let's check our answers. So over the equator, the air is wet and air pressure is low. So what's happening? Sun is intense at the equator. That means high insolation. It heats the earth, which heats the air above, and water on the earth evaporates into the air. Warm, moist air rises and cools. Water vapor in the air condenses, forming clouds and rain, and the cooled air starts to sink north and south. Our second step is over the Sahara, which is dry and air pressure is high. Cool air falls and is warmed, so no condensation happens, so the air is dry. As air reaches the ground, it diverges or spreads north and south. The third stage, which is over the poles, the air is dry and the pressure is high because it's falling. And the sun is diffuse or spread out at the poles, so air is cold and falls. Air diverges as it reaches the ground. And then the fourth stage is over the UK, 60 degrees north and south. The air is wet and the air pressure is low because the air is rising. Warm tropical air meets cold polar air. The warm air is forced to rise over the denser cold air, and this is called frontal rain. So we can see that across the world there are bands of low pressure and high pressure. Low pressure where air is rising, high pressure where air is falling. Low pressure bringing rain, high pressure bringing fair conditions. And now, we know in physics, don't we, in biology, that things move from areas of high pressure or high concentration to low pressure, low concentration. And it's exactly the same with the winds across the world. So if we mark these on, we can see that there are winds moving from 30 degrees north, an area of high pressure towards the equator, in both the north hemisphere and the southern hemisphere. And these are called the tropical easterlies, also known as the trade winds. And they're slightly curved because the spin of the earth kind of deflects them. And we have some winds moving from the 30 degrees north and south high pressure belt towards the 60 degrees north and south low pressure belts. These are called the prevailing westerly winds. And again, they're slightly bent because of the spin of the earth. And again, at the poles, we have air moving from the poles south towards that low pressure belt at 60 degrees north and south. And this creates some very fierce winds, particularly around Antarctica. And these winds, which are also reflected in the ocean currents underneath the winds, affect climate. And we know, don't we, if you look at the prevailing westerly winds that is flowing from the Caribbean towards the UK, we know that that is the Gulf Stream, which keeps our climate a lot warmer in winter than it would normally be. If we go back to the satellite photograph, which we were looking at the beginning, you can see now that you've got the low pressure belt at the equator with the clouds, and then a little bit further north you've got the clear skies over the Sahara Desert, and a little bit further north you've got the temperate lows over the UK, and the same mirrored in the southern hemisphere. And you can actually make out those winds flowing from areas of high pressure to low pressure. So as a final task, let's try and link the vegetation in the world to the climate. And if you look at the top left satellite photograph, you see the darker areas of green are where there's most vegetation, and the paler areas is where there's least vegetation. And you can see how those areas correspond to areas of high pressure, where the air is falling and is dry, to areas of low pressure where the air is rising and it's wet. You can see the yellow dots joining the right-hand globe to the left-hand satellite photograph. What I want you to do is try and answer those questions 1 to 7 in full in your books. If you need help, do have a look at that YouTube explanation that links to the Living World section of the syllabus. You could also have a look at this David Attenborough video, where he explains the location of deserts around the world. That's really useful. So let's go through your answers. Well, first of all, vegetation at the equator is very thick, lush vegetation. It's got the high biodiversity in the planet. And that is because, one, it's very warm because the sun is very intense there, but also it's very wet because the hot air is rising, cooling, condensing, and you have rain. And plants love warmth and moisture. Number 3, what's vegetation cover like at 30 degrees north and south? Well, this is where you have your bands of desert, like the Sahara Desert. There we are in northern Africa, is the one that stands out. And this is because the opposite is happening. Air is falling here, so no condensation is happening, so there's no rainfall. And so it's very, very dry, and too dry for all but the best adapted plants to grow. Over the UK, you have air that is rising again, and so we have a wet weather. It's not as hot as at the equator, but it's pretty good for vegetation. So we again have forest cover. We have temperate forest here, not tropical forest over the UK. And then finally, number 7, over the Antarctica, the air is falling, so no condensation is happening, and it is very dry. It actually very, very rarely snows in Antarctica, but the snow that is there doesn't melt, so it just accumulates over hundreds of thousands of years. So in terms of the syllabus, you need to be able to explain where air is rising, where air is falling, and how that impacts the vegetation that we get in different parts of the world. As an extension task, have a look at these 2 satellite photographs. Both have got Africa in them, and you can see the equatorial low pressure belt, that rain belt, that band of clouds across Africa, but it's in different places. So in the left-hand satellite, that rain band, that cloud band, is much further south than in the right-hand satellite photograph, and that's because it's taken at different times of year. You know that the globe is tilted a little bit, so the equatorial low pressure belt isn't always directly over the equator. It will go to wherever the sun is shining most intense. So in the summertime, in the northern hemisphere, the rain belt will shift slightly north, and when it's summer in the southern hemisphere, the rain belt will shift slightly south to wherever the sun is most intense around the equator. So in the left-hand photograph, that is summertime in southern Africa, and in the right-hand photograph, it's summertime in northern Africa. And this rain belt is incredibly important because there are countries that are on the edge of the deserts that wait for this belt to move north and south so they can get a little bit of the rain. So they wait for their annual rain belt. And if that belt doesn't move far enough north or far enough south, it can lead to huge drought and all the consequences of drought like famine. like you can see in this photograph of somebody who's a farmer. It's famine, not much grass is growing there, and it looks like the animals either died or had to be killed and people have had to move away. So this intertropical convergence zone and the way it moves north and south a little bit through towards the summers is incredibly important and has a huge impact.